Rolf, it's great to have you here with us on the Mars Kickoff meeting, which is almost at its end. Could you please briefly introduce yourself and say where you're based?
Yep. So I'm Rolf Altenburger and I work at the Helmholtz Centre for Environmental Research in Leizig, Germany.
Mm-hmm.
I'm head of a group that's called Bioanalytical Ecotoxicology. So what we try to do there is we try to develop tools to analyze and predict the effects of mixtures, that is their combined effects, and use that for water quality, for monitoring, for assessment of chemicals.
Mm. You're not a member of the Mars consortium, so
That's right.
what is your link to Mars?
Well, if you try to make it simple, the Water Framework Directive is sort of the common frame for three projects: Mars, Globe Aqua, and Solutions. I'm from the Solutions team. And what it does is the Water Framework Directive basically decides on water quality from two perspectives: the ecological perspective, taking biological quality elements into consideration, and that is what Mars is trying to modernize and to bring new tools into. And we, on the other hand, in Solutions, go for the chemical quality. That is, we look into tools how to assess contamination and effects of contamination.
So the differentiation is a little bit with these three projects that you mentioned, Mars, Globe Aqua, and Solutions, is the stresses that are considered.
Yes, in a way we are very specific on one type of stresses, chemicals, contamination, but we try to link that as sort of a major driver or possible major driver for ecological quality. And of course we need the expertise of ecologists to understand our findings.
Okay. So what kind of chemicals or contaminants are you dealing with? Can you give an example on that?
The chemical universe is just so large that it is difficult to find out which chemicals are relevant in a specific setting, that is in a river basin. So what we're currently doing sort of on the monitoring level is we have a consented set of 41 chemicals, while to give you a number, we deal commercially with more than 14 million chemicals. So that's sort of the basis where we have to start from. And if you think about transformation products, about mixtures of chemicals that occur, and possibly their combined effect with other adverse stresses, you see that there is no easy answer to your question which chemicals you deal with.
14 million is quite something.
Yes.
So where do all these chemicals come from? I mean, are there major pollutants or major effluents?
Well, of course, not all those 14 million chemicals we just mentioned are contaminants to the aquatic environment, but well, basically they come from our innovations. I mean, we have to realize that with chemicals in everyday use, we have some 100,000 chemicals that every one of us basically uses. And there's a constant turnover, constant innovation in the different areas, be that pesticides, biocides, pharmaceuticals, personal care products, and so on and so forth. And now for the water quality management issues, the challenge is to not only go for legacy compounds, sort of the old stuff that's easy to analyze, that we know for many, many years or decades, but that are of no concern anymore and of no management perspective, but rather go for what is a specific problem and to identify and prioritize the specific problems that we have at certain sites.
Ah, that's really interesting. The Mars project has a focus, or one of its focuses, on the effects of multiple stresses.
Yes.
Is this also something that you are going to tackle within the realm of solutions?
Well, we are certainly going to have to link to it, because of course we are not claiming that chemicals are the one and only thing in the aquatic environment. Take water scarcity, for example. So far we very often thought that flood events bring in a lot of contamination from streets or from drainage from agricultural fields. That is true, but however, you at the same time have high flow volumes, that is high dilutions. Whereas on the contrary, if you have water scarcity, we learned here on the Iberian Peninsula that in fact you have a simple effect of concentrating this, sort of the pollutants that you have out there, because the sideline activities implying chemicals for, say, the wastewater or from agriculture stay the same, only the volume again now decreases, so you get increased concentration and possibly effects from chemicals.
So usually people tend to think that these stresses act somehow in addition, so that if you add another stressor, it adds something. But I think this is not always the case. There's also some other, let's say, interactions between stresses. Have you already examples?
First of all, we have to realize organisms in the environment, communities in the environment are typically exposed not to individual stresses, not to individual chemicals, but to mixtures. Having said that, that doesn't mean that each component that's present or each stressor that's present immediately produces effect. However, we have learned that if we understand on a process basis or on a quantitative basis the effect an individual stressor can have, we also have means for, at least for the chemical contamination, to predict combined effects from sort of mixture presence. From chemicals, we have examples regarding pesticides being present in cocktails. I mean, if you have a runoff event, you always get runoff from many fields, so different chemicals. And of course, it can be easily shown that chemicals that are different but do the same thing with the biology, say herbicidal activity, add up in their effects. So if you do sort of a compound by compound assessment, you would be surprised about the effect and would claim it to be synergistic. However, if you do consider that you have knowledge about the individual effects and make an expectation, very straightforward, simple expectation of sort of the one compound diluting the effect of the other or concentrating, you would have an expectation for a mixture effect, and for chemicals at least we can see that this very often already does a job.
Suppose you would have the impact or the power to change the Water Framework Directive or to bring in new aspects. What would be your suggestion, especially for the revision of the Water Framework Directive, which is due anyway by 2019?
Well, first of all, I have to say that I think the Water Framework Directive is a great piece of legislation. I mean, the comprehensiveness and the objectives are, they really revolutionize what we do in water quality management, water quantity management in Europe. I think there are three things that we could achieve or could strive for, at least, with those projects and those findings. First is that we'd like to strengthen the position of causality-driven measurements. And I mean, taking on board, for instance, the multiple stressors, the mixture issue as a new element. And finally, I think we could think more cleverly about the exemption rules. I mean, many water bodies in Europe run under the exemption rule, and we could strive to be more ambitious with the goals that we achieve there. And again, the project results here could provide leads of how to do that more cleverly.
Excellent. I think this is really good closing word for this interview. Thank you very much, Rolf. It was
Thank you.
great that you had the time to come.
Thank you.
Thank you
for your interest.